Hello everyone, today we're gonna know how to design primers for PCR. The one thing you have to keep in mind is following the Wallace rule for melting temperature, and the GC content of your primer should be 40 to 60%, the minimum, and the annealing temperature is just less than 5 degrees to the melting temperature, and the optimal length of the primer should be around 17 to 28 bases. So today we're gonna use Pick Primers tool from NCBI website to obtain the primers for your sequence of interest of your desired gene. So let's begin today's video on how to design primers for PCR. Initially, just type NCBI in Google and click on NCBI website and change all databases to gene and type on your desired gene and the organism that you want. Here I'm using OPN4 human as an example and click on search. Once the page loaded, click on the gene that you have chosen and scroll down a bit until you see the gene bank. Click on the gene bank. Once the page is loaded, you can see you have to decide which exon that you want to create primers for. Here I'm choosing isoform 1. So I have gone into the CDS region of the gen bank to know the position of my exon 2. So we can count the positions like first exon, second exon, third exon. Like there are around 10 exons in the isoform 1 of melanopsin. So here I'm gonna choose exon 2 today to design primers for that exon 2 so that we can amplify the region of exon 2 using those primers in the PCR. So here you can see numbers from 2661 to 2806. So note these numbers for the further process. So to know the position of your gene on chromosome 10, which this gene lies on, scroll to the top of the page and you can see the chromosomal position of your gene in the region of change region shown. So you also note down these numbers to know the position of your gene on the chromosome, which is required to design your primers. So just note it down the from and to positions of your gene on the chromosome. So to give the detailed understanding of position numbers, I have drew a picture. So the top line, it represents the whole gene which has all the 10 exons which lies in the chromosome position between 8665345 and 8666460. So all our exons of isoform 1 lies in these positions of the chromosome, but today we wanna design primers for only exon 2, so we have to know the chromosome positions of exon 2. In order to get the positions, we use the numbers that we have obtained from the CDS region of exon 2, which are 2661 and 2806. So to obtain the beginning of our exon 2 chromosome position, we add number 2661 to 8665345, and always remember when you are adding the bases you have to subtract 1, and then when you're subtracting the bases, you have to add 1 to equalize the number of chromosomes position of the gene. So when you add 2661 and subtract -1 to 8665345, you get the beginning of the exon 2 chromosome position, which is 8665655. And to know the end of the chromosome position of exon 2, you subtract the difference between the CDS numbers, which is 145, and add to the beginning of the chromosome number, and then the number you get is 86656,300, which is the end of the exon 2 chromosome position number. So to amplify all our exon 2 sequence, our primers should not lie in these regions or at the beginning of these regions, but there should be at least 100 to 300 bases apart from the either regions, which to obtain the complete sequence of exon 2. So to get the position of 300 base pairs on the both sides apart, so we subtract 300 from the beginning chromosome position of exon 2 to obtain forward primer, which is 86655,856, and in a similar way, to obtain the position for reverse primer, we add 300 to the at the end of the exon 2 chromosome position, which is 86656,300 plus 300 base pairs -1, which gives 86656,599. So our primers lies in the position of 86655,856 to 86656,155 for the forward primer, and for the reverse primer, our primers lies in the position between 86656,300 and 86656,599. So record all these numbers of from and to positions of your gene and of your desired organism that you are designing for, because we will use these numbers in the Pick Primers tool of NCBI website. So now click on the Pick Primers under Analyze the Sequence and type the forward primers from and the to regions and the reverse primers from and to regions, which you have noted down before. And the from region of forward primer is 86655,856, and the to region is 86656,155, and the from and to regions of the reverse primers are 86656,300 and 86656,599. You have to note down the from and to regions of your chromosome according to your chromosome position of your desired gene that you are doing. And once you have typed in all the forward and the reverse primer from and to positions, just scroll down the page. And change the database to genomes for selected organisms, and click on show results in new window and click on get primers. This page takes around like 2 to 3 minutes to load and to obtain your results. Once the page has loaded, you can see the graphical representation of the gene, where is the exon 2 in the green colors box. and they give the detailed primer reports, so you can check the GC content is near to 60% or not. The more the GC content is, the better the primers. And also check the annealing temperature should not be variant more than 2 to 3 degrees centigrade, and make sure that melting temperature is closer, like the forward and the reverse primers melting temperature. So you can analyze all the primers that they have suggested and choose according to the rules of the GC content and melting temperature and the length of the bases. I hope this video is helpful. Please like, share and subscribe. Please let me know if you have any doubts in this video in the comment section, and I will reply to your messages. Thank you.